Ljiljana Progovac is a formal syntactician. That is, a person who studies the structure of phrases and sentences within a theoretical framework most closely associated with Noam Chomsky. As a syntax specialist, she is the author of the books Negative and Positive Polarity, A Syntax of Serbian, and is co-editor of the Syntax of Non-Sententials. She has also authored numerous articles on syntax that have appeared in journals such as Linguistic Inquiry, Journal of Linguistics, and Lingua. But for the past 8 years, Ljiljana has been involved in a new project, one exploring the interconnections of syntax, biology, and genetics against the extensive literature on the evolution of species and natural selection, in order to arrive at a new understanding of how the complex syntactic structures of human language may have arisen as adaptations in response to evolutionary pressures. She will be presenting the latest piece of this ambitious project today, one which has taken her far from her early work in pure syntactic theory, conducted in the comfort of her office, into the fMRI lab in the hospital. Ljiljana's work is truly interdisciplinary, but not superficially as that word sometimes suggests. It is securely grounded in her home expertise in syntax. But it is bold and ambitious, since it is required that she read both widely and deeply in areas brand new to her: typology, biology, physical anthropology, brain science, genetics, animal communication, and others. As all great ideas, hers seems simple and reasonable, that complex linguistic structures evolved gradually from very simple structures, bedrock structures that are still evident today in modern languages. It nonetheless runs up against another hypothesis, that the whole magnificent architecture of modern syntax emerged in a single mutation, as the outer manifestation of thought as inner speech. Some very powerful people hold this latter view, including Chomsky himself. So Ljiljana has had some serious arguing to do with some seriously smart people. And as can be seen by the number of invitations she receives to lecture and the number of times her written work is solicited, she is beginning to win people over. Ljiljana has spoken at conferences on language evolution in the US, England, Spain, Poland, and the Netherlands, has had 3 papers on the evolution of syntax published in the journal Biolinguistics, and has published a number of chapters in important books on related themes. As a result of this work, more recently, she has been repeatedly invited to give keynote presentations on the evolution of syntax at workshops and symposia, such as those at Yale University, back home in Novi Sad, Serbia, at the University of Washington, the University of Virginia, and the University of Connecticut. Oops, I think I forwarded into your talk. I'm doing your presentation. I'm reading on the keyboard. Oh, okay. How do I go back? Anyway, no, just don't read that. Don't read that. Okay. She's also been invited to share her work at the Duke University Institute for Brain Sciences. In addition to regularly offering seminars on language evolution at Wayne State, she has also been invited to teach an advanced seminar at the LSA Institute at the University of Chicago this summer, entitled A Program for Evolutionary Syntax. The culmination of these years of work is the tightly argued, persuasive, and brilliant book, Evolutionary Syntax, which will be published this spring by Oxford University Press. I'm happy to say that I've had a chance to read the manuscript. Of the many glowing things I could say about this book, I will limit myself to just 2. First, in science, you know someone is on the right track when he or she takes what appears to be a complex tangle of a problem and shows that it is not a problem at all when looked at in reverse. In this case, the problem was figuring out what a set of disparate so-called syntactic island constructions have in common, a problem people in syntax have been wrestling with for decades. This is a problem that simply disappears when viewed from an evolutionary perspective. I know I haven't explained this adequately, but I refer you to her magnificent Chapter 5. Second point, in science, you also know that someone is on the right track when his or her hypothesis explains a whole train of seemingly unrelated phenomena. In this case, child language acquisition, emergent sign languages, the breakdown of syntax in language disorders, and now perhaps also syntactic processing in the brain. On both of these measures, Ljiljana is decidedly on the right track. I am honored to have had such a wonderful, stimulating colleague for so many years, one from whom I have learned so much. And we all benefit indirectly from her work, since she has enhanced the name and reputation of Wayne State University in this country and around the world. It is a great privilege for me now to turn the floor over to Professor Ljiljana Progovac, winner of one of the two 2014-15 Marilyn Williamson Distinguished Faculty Fellowships, to give her lecture In Search of Proto-Syntax in the Brain.
Thank you so much, Martha. From here, everything can just go downhill from this presentation or introduction. But Martha has been a mentor, I would say, for the project that I have been exploring, because I have always consulted with her on every idea, every aspect of this, and she was always there. And it was only when I thought I persuaded her that I thought I was ready to share these ideas with the outside world, so to speak. Thank you, Martha. This is a joint project with Dr. Noah Offen, who is in gerontology. She's a neuroscientist, and research assistants are William Angel, you can wave. He's in computer science. Margaret Ruth Crabtree, she's a linguistics student, MA student, and Ivan Alonso, who is in communication sciences and disorders. This is an amazing team, and we are learning so much together, and we are learning so much from each other. I'm very grateful that we have been able to put this team together. I am so grateful to this Distinguished Faculty Fellowship, Marilyn Williamson Fellowship, to the Humanities Center, and to Professor and Director Walter Edwards, because this is really a unique opportunity for me to do this kind of interdisciplinary, truly interdisciplinary research, trying to intersect the fields that seem so different, use such different tools, as is syntax, linguistics, and neuroscience. Often the greatest questions, we all have questions, great questions about humanity, but often they can be answered by breaking them down into small and testable hypotheses. And testing them often requires resources and insights of multiple fields. And that is clearly the case here with this project, which looks at language evolution and language representation in the brain. I have so many people to thank, and this is not even a complete list, but I want to say that in addition to Martha Ratliff, many people who are here in this room have either discussed this with me extensively or even co-authored papers on this or related topics, and I'm very, very grateful to all of them. So this project is at the intersection of syntactic theory and neuroscience, but it is mediated by a novel approach to the evolution of syntax, which I have explored in my papers and now in the book. The technology that we are using is the fMRI technology, and this is our team that I already introduced. So this is a pilot study in progress. We are looking at testing 14 subjects total, 7 English-speaking and 7 Serbo-Croatian speaking, in the MR facility at Harper Hospital. They spend about 1 hour in the scanner exposed to the written stimulus while their brain activation is being recorded. So far we have tested 4 subjects, but in addition to that, we have assembled the team, trained the team, put forward all the paperwork which has been approved. We have created the experimental design, and now we are almost on a weekly basis, we are testing the subjects one by one. This is a picture in the MR facility with Pavan, who is a technician there. We really need a lot of their help too, and they have been very helpful. So, what are some great questions that we often ask ourselves? Well, how about how and why language evolved in humans? How and why did the brain evolve in humans? What made us human? And also, are these questions related? Some great minds think that they are. So for example, Gould and Chomsky have claimed that human language, or more precisely grammar, syntax, can be a byproduct of the increase in brain size. They leave a kind of passive role to syntax and language, I would say, because their view is that the brain evolved for some other reason, yet unknown, and that once it did, language was able to happen at that point. On the other hand, Deacon, for example, and some other people, have argued that actually it was language that forced the brain to evolve. That basically this expansion of the prefrontal brain regions was an evolutionary response to a sort of virtual input with increased processing demands. And more specifically, Deacon's proposal is that language structure arose in a drawn-out coevolutionary process in which both the brain and language structures would have exerted selection pressures on one another. If this is true, then we should expect to find that human brains exhibit species-unique modifications that fit the unique processing demands imposed by language. And if so, then we should be able to probe that and find evidence of that in neurolinguistics, in the brain. Darwin, by the way, had the same view. His claim or idea was that as soon as language came into use, the continued use of language actually would have reacted on the brain and produced an inherited effect. And this, again, would have reacted on the improvement of language. Again, this is the idea behind the co-evolutionary process. Darwin also said that the largeness of the brain in men may be attributed in chief part, he gives the role of language the chief part, to the early use of some simple form of language, which he calls that wonderful engine, which affixes signs to all sorts of objects and qualities and excites trains of thought which would never arise from the mere impression of the senses. He he was a little bit of a poet as well as a scientist. However, there have been claims or conclusions on the part of, for example, Peppel and Ambig and some other neuroscientists claiming that current neurolinguistic research presents a case of cross-sterilization rather than cross-fertilization, because no meaningful correlates have been found between biological units of neuroscience, including neurons, dendrites, axons, and the highly abstract formal syntactic principles such as subjacency, case, theta criterion. Obviously, yes, that does seem like something that will never be matched, but it also means that a new angle is needed. And this is exactly what we're exploring here, trying to bridge this divide by using a neuroscientific method to test how protosyntactic structures, simpler structures, are processed in comparison to their more complex counterparts, because this is something that the neuroscientific subtraction method can do. So evolution is the missing ingredient, is what I argue. And the basic postulate is that evolutionary considerations are the missing piece that is necessary to bridge the gap. So one can find the idea, the hypothesis is that one can find precise correlates of syntax in the activity of the brain by decomposing syntax into its evolutionary primitives and then comparing how these primitives, or what we call living fossils, are processed in contrast to the more fully developed syntactic structures. So one cannot just find a relative clause in the brain or accusative case, but one can construct sentences that only differ with respect to that one little feature and then see how they are processed differently. That is the idea. What are language fossils? Jackendorf was the first one to suggest that previous stages of language are still present in our brain, but also that the fossils are present in the grammar of modern languages. And I have taken that idea much, much further and identified what specific syntactic fossils there might be, and also not just in English, but in other languages. And also argued that this simpler syntax is built into the very foundation of more complex syntactic structures, that we could not have ever had these complex structures had it not been for this scaffolding, this simple structure that was in place first. If so, again, one expects to find some evidence of it in the way that the brain processes language. What is a living fossil in biology? There is one example of it, and a picture of it. It's a lungfish. Living fossils are defined as species that have changed little from their fossil ancestors in the distant past. So the same idea with language fossils. They have not changed very much. They continued to live alongside with more modern constructions. Some examples of these so-called living fossils, they are used often in marginal constructions. They are often referred to as small clauses, compounds, middles, etc. I will not have time to introduce them in great detail, but here are some examples. Me first, Wayne first, everybody out, pickpocket, killjoy, crybaby. Typically two-word combinations, simple two-word combinations without much grammar. According to syntactic theory, minimalism, as Marta pointed out, so my reconstruction of these stages of syntax is based on this theory, Chomsky's theory, that that a sentence structure actually is a hierarchy of different layers of functional projections. So we have the inner layer, which is the verb phrase small clause layer, which typically accommodates just the verb and just one argument. And then there is on top of it a light VP layer, which is the transitive layer, which accommodates an additional argument in transitive structures, the agent typically. And then we have the tense phrase, which accommodates the expression of tense and finiteness. And then we have the CP, which accommodates embedding, questioning, etc. So my reconstruction method is a very precise method based on the theory. So I tried not to have it be impressionistic or ad hoc, but rather I'm basing it solidly on the theory of syntax. And the method basically says that a very simple proposal that structure X is considered to be evolutionarily primary relative to structure Y if X can be composed independently of Y, but Y can only be built upon the foundation of X. It's well known in syntactic theory that the small clause and VP can be composed without the TP or tense layer, whereas the TP must be composed on the foundation of the small clause or the VP. So one can reconstruct a TP-less, tenseless, and CP-less stage in the evolution of syntax. One can even remove the transitivity layer, the light VP layer, because again, the light VP layer must be projected on top of the small clause / VP. But not vice versa. So we can reconstruct an intransitive and tenseless stage, which really now only reduces to the so-called small clause or VP structure. So this is a surprising and novel conclusion, because even common sense or ad hoc approaches did not arrive at this conclusion, that this stage has to be intransitive, a stage where subjects and objects are not really distinguished. So how does this work? These are some derivations. For example, if we have Maria will roll the ball, or the ball will roll, both of these sentences start as a small clause, roll the ball. And now, if you're only going to derive the ball will roll, we only need the tense phrase. If you're going to derive Maria will roll the ball, then Maria first merges in the light VP the transitive phrase, and then we merge the tense phrase, so we have 3 layers. Similarly, with the problem will be solved, we can start with a small clause problem solved, and then we can add the tense phrase as another layer and derive the problem will be solved. Exactly the same theory carries over to other languages. That theory is meant to be a universal theory of grammar. It carries over to Serbian data. Also a small clause transforms into a full sentence by adding a layer of tense phrase. What is really interesting about this theory is that, and this is one of the most stable postulates in the theory, is that the small clause is at the heart of every sentence. So every sentence begins as a small clause, unfolds from the small clause. So if it's true, then it is as if the building of the modern sentence retraces its evolutionary steps. And again, the question is, can this have some evidence in the brain? Postulating the intransitive stage allows for a fine-grained identification of stages, as well as for identifying the communicative advantages for evolving hierarchical grammars, including transitive. It also sheds light on vast variation across languages in how they express transitivity. And it also sheds light on so-called middles and many other transitional structures. The experimental design basically uses the subtraction neuroscientific method to test the processing of these distinct structures in English and Serbian, tenseless versus tensed, mission accomplished versus the mission was accomplished. Also contrasting different types of compounds, simple, flat, fossil compounds like pickpocket, killjoy, turncoat, crybaby, which by the way, are all of them almost across languages are derogatory, which is another story on its own. But versus more complex hierarchical compounds such as joy killer, head turner, heartbreaker, the same in English and Serbian, exactly the same contrasts. And then also Serbian has a very clear category of a middle grammaticalized category, which contrasts minimally with the true transitives. Se is used in middles, and the middles are vague constructions, which can mean almost anything, as you can see from these translations. Minimally contrasting structure in two disambiguates and is precise. It's a transitive structure. It can mean only one thing. According to my analysis, the middles are more primary, evolutionarily more primary. And there has been a lot of it is well known, linguists know very well that there are lots of different middle, transitional, ambivalent structures like this, which straddle the boundary between transitive and intransitive structures, between passive and active, between subjecthood and objecthood. And this is exactly what a gradualist evolutionary approach predicts. What are our specific hypotheses? So very broadly speaking, the processing of hierarchical, tensed, and transitive structures will show more lateralization in the left hemisphere of the brain and more specialized activation of the Broca's area as well as other syntactic areas, while on the other hand, the processing of these fossil or protostructures, tenseless, intransitive clauses, flat compounds, middles, is hypothesized to be more widespread, diffused in the brain to show less involvement of the Broca's and other syntactic areas, to show less left lateralization, but more reliance on both hemispheres, as well as possibly more reliance on the subcortical structures of the brain. The method is the subtraction neuroscientific method, which subtracts the brain images associated with one construction from those of another, isolating the differences between the two. So we present a visual stimulus, and this is an example of how that works. What kind of stimulus the participants get while in the scanner. Okay, so, let's check. Well, okay. So the participants are exposed to one phrase after another, basically, and then we are recording how the brain, what lights up in the brain, basically, during that process. Now I will give the floor to Ruth and then to Will, who will introduce some additional slides.
So it's just a basic introduction to the kind of information you're going to see, because the fMRI scans are three-dimensional. I'm sorry, because the fMRI scans are three-dimensional. So you're going to see like one or three different images on one side, which are all the same information, just from different perspectives. So to either see the outside of the brain or these slices that sort of show, something's happening deep in the brain so you can actually see where it is. And the Broca's and Wernicke's are sort of canonical language areas that we found a little bit of activation in. So these are very preliminary, so each of these are one participant. We're expecting to have 14 total. But so far it looks like this matches up with our theories. This shows that there's more diffuse activation for small clauses over full sentences, which means it sort of takes more different areas to do something that seems like it should be simpler, but that's not the case. And this is simple compounds activating more of Broca's area than small clauses in English, and this is on the outside of the brain as well.
So for our Serbian subjects, we looked at the contrast between transitives and middles, so syntactically complex versus simple, and this is what that's showing. It's just the same activations being shown here, but different viewpoints. So we found that there's higher activation in the Broca's area for the syntactically complex, supporting our hypothesis. Similarly, for full SV subject-verb sentences versus imperative middles, we found that there's higher activation in the Broca's area as well as some activation in the Wernicke's area.
Thank you. I do want to stress how preliminary these results are. We have only looked at 3 subjects. We have tested 4, only looked briefly at 3 subjects, and we are hoping to find more evidence of our hypothesis. And we are also open to whatever the results show us. If we do not find evidence for some of these, we'll have to revise our thinking. And maybe we will find something that we did not anticipate, that then we can deepen or go back, formulate other hypotheses about that. So there has been research, previous research, that has identified Broca's area in particular as consistently linked to syntactic processing. And there have been reports that increased syntactic complexity corresponds to increased neural activity. And we are building on those results. These results are helping us formulate our hypothesis. There has also been findings that formulaic uses of language involve more ancient processing patterns, including more involvement of the basal ganglia, thalamus, limbic structures, and the right hemisphere, which is potentially relevant to us because many of these living fossil structures in fact tend to be formulaic, which is another connection with the evolutionary considerations. Also, Ullman has found, a neuroscientist, that Broca's area is part of a larger circuit that involves the basal ganglia, that the 2 parts are densely interconnected and both are implicated in language processing, including syntax. Speaking about genes and language and the brain, it has been reported that a mutation on FOXP2 gene seems responsible for a specific language disorder, which is characterized by a delay deficit in the use of auxiliary verbs, tense, and agreement, which are tense PP elements, as well as causation and transitivity, which are light VP elements. Some recent experiments suggest that the specifically human FOXP2 mutations are responsible for growing longer neurites, axons and dendrites in the brain, establishing better connectivity among neurons. And this work was done by copying human mutations into the FOXP2 of mice. There is a great potential for synergy, we believe, where the syntactic theory, linguistics, can identify proto-syntactic structures and distinguish them precisely from more complex structures. Neuroscience can test if these distinctions are correlated with a different degree and/or distribution of brain activation. And genetics can, among other possibilities, shed light on the role of some specific genes in making such connections in the brain possible. And evolutionary biology can provide a framework for selection of relevant genes. And thank you very much. I think we have time for questions. Yes.
Are there gender factors in your research,
Excellent question.
especially in terms of lateralization of language or?
Absolutely, excellent question. Yes, there have been reports, including by Ullman, that same reference that I quoted, that especially syntactic processing might be more lateralized in men than in women. That in women, the processing strategies might be more bilateral. So yeah, this is absolutely possible. We are trying to find both male and female subjects, and we'll see what happens. No.
We won't have enough power in this limited, so
Yeah.
once it goes
Yes.
into a measurement, you need to have enough of that to significantly tease those apart. But
Yeah.
ultimately, yes.
With our pilot project, we definitely will not have enough evidence to tease those apart. But yes, in a bigger project, we could control for that and compare. But that's a great question. Yes.
Are the stimuli that your subjects are exposed to visual or not oral, not acoustic?
Yes, they are visual. Yes, they are visual. I wasn't able to get them to show, which is a complication. But with the fMRI strategy, it would be much harder to test oral, to test this. But that could be something we can do, because a bit of an issue here is that there is this overlay of literacy and clearly complexity that comes with that. So it would be definitely better if we could do the oral version, and maybe sometime in the future we can consider that. fMRI is extremely loud. It's extremely loud, so it's designing the experiments to do this orally would be extremely difficult, but definitely desirable. Yes.
I'm interested in what you have right on the screen there about formulaic use of language. I wonder if you or anyone has looked at language becoming formulaic. Easy example, the mother of all X, which was not a fixed expression and became one, and then it's a meme. It goes out in all directions. X can be almost anything these days. I wonder if you would get the same effect over quite shallow time, like decades rather than millennia, if you looked at the development of such memes.
Yeah, I think that most of these formulaic expressions were once probably productive.
Yeah.
So even something like, I have one example, which is come winter, we will all go to Florida or something. So once productive, and then somehow got fossilized. Yes, this happens all the time. And nothing stops this process. So if this happens in the evolutionary times in a sort of long and protracted way, there is no reason for this not to happen on a faster scale in the more modern time. Steve?
Yeah, building on Margaret's question a little bit, I'm interested in these compounds, because obviously a compound like pickpocket, in a historical and a diachronic perspective, must follow the existence of pick and pocket, both independently existing within. I mean, I don't think that pickpocket emerged from the picker of pockets or something like that.
No.
I think we have pick and we have pocket, and they've kind of become put together. So, and I get what you're saying, that really they're more appealing to evolutionary primary structures. But on the other hand, historically, they're later. They emerge after the individual components of which they're constructed.
After the words?
Yes, and after the use of these words in fully syntactic
We don't know
expression.
that. We don't know that. If they emerged after. Okay, about, yes, these compounds are fascinating. I have actually co-authored a paper about them. Okay, so my idea, and you can tell me if it's wrong, is that, first of all, the idea behind this syntactic evolution project is that we first had just words, a stage without syntax, where we could just use one word and say run, pick, apple. And that the simplest possible stage of syntax then emerged, which is to just combine two words together, no other grammatical devices except for this just simple combination. And that what is interesting about these compounds that I haven't had a chance to talk about is that they do not grammatically distinguish between subjects and objects. That's why they are so interesting to me, because you have crybaby, where baby is the subject of crying, but then you have killjoy, where joy is the object of killing. And there is no different marking grammatically of these. So the idea is that that was how the first combinations were. That you just put together two words without, that first mold was not meant to distinguish subjects and objects. It was just supposed to put together two things. And then the idea is that the really surprising thing is that these are all derogatory. They are like insults in language after language. So the idea is, in that paper that we wrote, is that when these are created, they are using that old mold, that living fossil that we still have in our brain, that we can still use. Even today, you can use these very, very derogatory, obscene combinations of a verb and a noun. So we are using that mold, that old fossil mold, to create this. But it doesn't matter that we now have more complex structures. We are able to juggle between the two. So that's kind of the idea. Yes, Maggie.
If nobody else wants to, I'll follow on Steve, which is that I think what throws the argument here is that every one of them means something more and different than the pieces. So
okay.
I think that's a little of what you were getting at also.
I mean, I understand the point. I like it. I guess I want to know what the historical evidence says, if anything. In this case, it doesn't, from your model, it doesn't actually have to say anything at all,
No.
because we could constantly be appealing to this pre-syntactic or or proto-syntactic module, or whatever you're going to call it,
Mold, yes.
that allows you to generate.
Yes. Okay. So the idea behind, so yes, of course, we now when we form those compounds, they kind of converge on a certain interpretation, and we remember them and we store them in the lexicon. The idea was that at the very beginning, suppose we are in a one-word stage and people are trying to throw insults at each other. You had to be really creative. You had to choose two words that are going to be able to mean something completely new that you could never express before, with the words that are concrete, that are very concrete, to express something that is abstract, for which you surely did not have a word at that point. So look at scatterbrain. It's such a beautiful metaphor. It's, and do we even have a better word today that is, that is abstract? It captures an essence of a characteristic of a person in just two words, that once you say them, the audience is supposed to put it together, and the one who says it is supposed to put it together on the spot. It would have involved a lot of creativity, and that's the idea. Those who were better able to use such compounds on the spot would have contributed more to the gene pool of the humans. That is the idea.
I think one interesting thing in the English data, at least, is that like the small clauses, when they moved into genres, I'm thinking about note taking, like baby clothes to Salvation Army, things like that. We appear to actually, well, this is speculation, but those particular structures, even though they're not in the formal language, appear to be better for certain genres like note-taking, and we found that in the recipes.
Yes,
and
in our
things like
joint
that.
non-substantial book project. Yes.
But, I was thinking, why don't they disappear? But the reason is, I think they've always been handy, and in fact are better at some functions than others. That would be really interesting to kind of tease out.
That's exactly the argument, that those, fossil structures are processed easier to process by the brain in some way, or processed differently, and they are useful for some constructions where we do not need more complex grammar. So we continue to use them, and alongside the more complex ones, and then we have more specialization. We can use, so structures like case closed, they specialize for a kind of formulaic, in the here and now utterance. So we cannot say, I think that case closed 3 years ago. We cannot embed them in some previous or future event. They really specialize, and that's why they can be so simple and quickly interpreted by the brain. So we don't have to say, oh, here in this moment I declare that the case is closed. We can just say case closed, and that's exactly what it means. So they are more economical in many ways. Yes.
So yeah, I have a quick question about the design of the experiment. So for the Serbian cases, you're testing the middles, right?
Yes.
Okay, so I just want to make sure I understand why you're doing that. So when I first saw the data from the flat compounds, you might worry that what you would really be discovering is something about like lexical processing versus bona fide syntactic processing, because you can try to argue that pickpocket has no syntax, it's just a lexical.
It has this rudimentary.
Yeah, maybe it could be constructed in lexicon, but the Serbian cases, this seems to be bona fide syntax.
Yes,
so
yes.
Is that why you're using
Yes, definitely. That's why. And what's interesting about these cases is they differ so minimally, but by one sound. So we also saw that there is nothing extra going on in the visual processing or elsewhere. It's really just in the Broca's area that we see, and it's So one needs to look for these contrasts in different languages, because different languages will show different kinds of fossils. Yes,
I was merely going to ask if you could help us import the marvelous phrase spin button to the English language.
there you go. Yeah, there are such beautiful expressions among these compounds. Yes, that yes, we can try that. Am I done? Yes. Thank you.